Hello, scientists! So today's episode, today's lesson is a little bit longer. I might need to do two videos, so just to warn you. So today's lesson starts with a warm-up as usual. This is module number 2, warm-up number 2. So please pause the video and try the warm-up and use your notes from module 1. Okay, super important that you refer back to your notes. So do that now. Okay, you should have completed warm-up number 2 using your notes. So today, in today's module, we are still going to be focusing on kinetic and potential energy, but we're going to specifically look at how they can turn from one to the other, back to the first one, back to the second one, and that's called energy transformation. So if you did not already get out your notes, which you should have, I need you guys to find in your science folder Notes 1 Energy Basics. Now, there's a link to it here, but don't click that link. Instead, go back and watch the video for Module 1 because you should already have these notes. Don't do these modules out of order. So, find your notes, go to your science folder, go to your Unit 4, I've got the power folder, and your note should be right there. Copy of Notes 1 Energy Basics. We did the first part last class, so this is it filled in. This is what you already should have used for your warm-up. So now we are going to do the second section, which is right here, Law of Conservation of Energy. All right, so here we go. So this is just a reminder that the Law of Conservation of Energy means that energy cannot be created or destroyed. So we did talk about this in our last module, but we didn't name it. So there's a name for this idea, and that's Law of Conservation of Energy. There's also a law of conservation of matter, which says matter cannot be created or destroyed. So energy and matter have that in common. Now, energy can be transformed from one type to another. So here's a kid rolling a car down a hill, or actually there's two cars, one's red, one's blue. This car has potential energy because it's at the top of the hill. This car has kinetic energy because it's down at the bottom, it's gone down the hill, it has speed. And if a car were to roll from the top to the bottom, it would be transforming its potential energy to kinetic energy. Today, we're going to learn how potential energy can turn into kinetic energy and vice versa, but the total amount of energy stays the same. So, actually, in 6th grade science, you should have learned this, but we know that this happened during the shutdown, and many of you probably missed instruction. So, this is a lot of what you missed in that last part of 6th grade science. So what we're talking about today can be demonstrated very well by riding a roller coaster. So I've embedded 2 videos here. Go to this section in the slideshow, pause my video, watch these. They're fun. This one on the right, Top Thrill Dragster, is one of my very favorite rides in the whole world, and it's very scary looking. So if you've never ridden it or would never even want to, I encourage you to watch this video. It's pretty short. All right, so now that you've watched a few videos of roller coasters, let's talk about potential and kinetic energy. So potential and kinetic energy go back and forth and back and forth and back and forth in many, many examples in the world. So here are just a few examples. Let's say we have a weight attached to a pulley. If the string is cut, the weight falls to the ground. That is one example of transforming potential energy from being high above the ground into kinetic energy when that weight moves and eventually hits the ground and stops. A swing is another example of this, right? So a swing goes back and forth and up and down and up and down and up and down. Well, at the highest point of your swing ride, you have all the gravitational potential energy, and then gravity pulls you down. At your lowest point, B here, you have all the speed on the ride, right? So then you go up and slow down and change directions, and it's like a pendulum swinging back and forth. So that's potential energy, gravitational potential energy, kinetic energy, potential energy, kinetic energy, potential energy, back and forth, like this. Now, it doesn't just happen with gravity swinging back and forth. It can also happen with our other type of potential energy, which is elastic. I'm looking for my rubber band, and I can't find it. Oh, because I flung it across the room. All right, so a balloon is a great example of potential energy turning into kinetic energy. So I'm sure you've tried this. You blow up a balloon real big and then you let it go, right? Well, it flies around the room, releasing all of that stretched out elastic potential energy. So when the balloon is nice and full, it has a lot of elastic potential energy, right? Because it's made of rubber, so it's a stretchy material. Then you let it go, all that air releases, and the balloon starts moving. That's kinetic energy, okay? Also, the air moves, which is also kinetic energy. Another example is a bouncing ball. At the top of its bounce, it has gravitational potential energy, and then it's moving kinetic energy, and then it bounces back up and goes through it again. You can probably come up with a few examples of your own. It applies to lots and lots of different things. So now we're going to take a close look and see how that energy changes along the route of a swinging pendulum. So we have a red ball attached to a string, and imagine it swinging back and forth, and we have 4 different positions along its journey. In most positions, between the first and the last point, the object has a combination of both types of energy. So let's start with 1. Let's say at 1, this is the highest point that this object is swinging. That is its maximum potential energy. This is the most potential energy it will have. Then let's say we freeze it in time between 1 and 3. So at point 2, this is where it has both. It has potential energy because it's a little bit off the ground. It's not down here. And it has kinetic energy because you can imagine it is moving. At 3, this is its maximum kinetic energy. This is where the ball will be moving at the fastest speed before it starts to go up and slow down. And then 4 is basically the same as 1. It's at its highest point, it stops for a quick second, it has potential energy, and then it turns back down, turns back around, and goes through it again. Okay? So there's a million different positions in between all of these 4 points, and most of those have some potential and some kinetic energy. And all the while, it's kind of seesawing back and forth. So let's take a look at a couple of examples. Here is a cannonball being shot into the air and going back down to the ground. Where along this journey would it have its maximum potential energy? Well, since this is an object going up and down, potential energy will be its highest point. So that's going to be C. C has the maximum potential energy. So what about the maximum kinetic energy? Well, where would this cannonball be moving the fastest? If you think about it, it'll be where it's closest to the ground. Right before it hits the ground, the cannonball is moving the fastest because it just gained a lot of speed due to gravity. So E has the maximum kinetic energy. Now, which points would it have both kinetic and potential energy? Well, basically all the other points. So A, it's above the ground, so it has potential energy, and it's moving. It just got shot out of a cannon, so it has kinetic energy. Same with B, same with D. Well, let's look at kind of the opposite situation. Let's imagine this is a roller coaster and it's moving from point A to point G. So it's going down a hill and then up another hill. Where would it have its maximum potential energy? So the maximum potential energy would be the highest point. That would be point A, not point G, because A is slightly higher. We can tell because of these horizontal lines. Now, where would it have its maximum kinetic energy? That's wherever it's moving the fastest. That's also, it can also be thought of as where it's closest to the ground. So as a roller coaster rolls downhill, it gains speed, right? That's what makes the ride fun. Once it gets to the bottom of the hill, it's gained as much speed as it will. So D has the most kinetic energy. Okay, now let's add a little bit more detail. Where along this track would would it have increasing kinetic energy? That means increasing speed, and decreasing potential energy. That means decreasing height. So think about moving from point A to point G. Where would its speed be increasing, but its height be decreasing? Well, that would be on its way down a hill, right? Increasing speed, decreasing height. So B or C would be good answers for this question. What about the opposite? Where would the object have increasing potential energy, meaning it's getting higher, and decreasing kinetic energy, which means it's slowing down? That's right, it's going to be points E or F. When it's going up the hill, it's gaining potential energy, but it's going to be slowing down because of gravity. So E or F. All right, I'm going to pause this video and start a new one so I don't run out of time.